All right, video 2. We want to now use the objects we've created in order to do something. Right now, all we can do is, so what we've created right now is an A that has a 1, 2 in it and a negative 3, 2. So they're both column vectors. They stay column vectors right now. We want to be able to not only print them to the screen, but actually do something with them. So, right. Oh, and the other thing is we forgot to do the second part. So this is called the representation method, and it's different. It's a little different than the string method. So the string method, if you do any kind of printing it out to the screen, or if you do a string typecast, then the object will know to go run this set of code right here. If you like hit Shift Enter in our case, because we're going to be in a Jupyter Notebook, or if you were in Spider and you hit F9, that's what would get executed, the representation or the repr method, right? So that's just again another special method that does that. So we want to do this one too, to go along with our string method, and I don't want to do anything different, so I'm just gonna call. Yeah, you'll see. We'll get to it in a second. Okay. So let's go ahead and bring this sucker up. So the other thing I just wanted to point out is I added more code to our string method, so that we can now print more than just column vectors. So before, this code right here printed the column vectors, and now what we've done is we said, okay, let me if it's a row vector, then this is going to be an error, because for row in self data, it's just going to be a number, and it's going to be an error if you try to iterate, or you try to slice through an integer. It'll give you an error. So then it'll jump to accept calls or your accept statements, and it'll execute that code. And that's what we wanted to do. I didn't want you guys to sit here and watch me do that, because it's not that big a deal. But we do want to do this. So shift here. Let me start this sucker over. Shift enter, and let's create these suckers. Let's print them. We see that the print still works. And then the question is, we don't want this. I don't want it to do this. I want it to do something like what it did up there. We're simply going to create the representation method. And this is very annoying that it jumps over. I don't know why it jumps over to the middle of the page. I'm sure I did something wrong. underscore REPR underscore self earn str self. Remember, if you typecast it as a string, it'll execute that code up there, and that's what will be returned. Okay. And then def. The next thing we want to, so we've taken care of that one. The next one we want to do is the invert. So what is the invert going to do? We want that one to be the transpose. So if I have a column vector, I want to turn it to a row. If a row, I'm going to turn it to a column. So underscore invert. Oh, and why is it called invert? And it's also a special something, because the way that you do it is this. Oh, we didn't. I didn't prove to you guys that this works, so we can prove it to you real quick, and then hopefully that one. Okay, so it does exactly the same thing. Now come back up here, press enter, come back in there. Yes. All right, so we're there, and so what do I want it to do? I want it to test something. I want to say if is instance of row 0, comma, a list, then we want to do self. So if it's a list, that means it's not a row vector. So we want to turn it into a row vector. So self.data, this is how we turn it into a row vector. Self.data, right? Because I don't have a row. There's no row anywhere in here. But self.data is something. It's either going to be a number or a list. If it's a number or a float or something else, then then we wanted to change it to a column vector. And if it's already a row vector, I want to change it to column. So this needs to be a column vector. I'm sorry, a row vector because it's a list. So self.data is equal to, let's see, self x dot y. And then if that's not true, we need to turn into a column vector. Doesn't work, we'll figure out why it doesn't work. All right. Return self. Return. Enter. And then we know what that one is. And if I do the inverse or the transpose in our particular thing's case, it does it. If I did it again, it would turn it back. And if I did it again, it would turn it back. So it just goes back and forth. Okay, that's good. So our inverse works. Now the next question you need to ask yourself is, what do you want it to do when you have two objects and you got a plus sign in between them? That's what this sucker right here is getting at. What does it actually mean if I did A plus B? So let's go back up here. Let's go backwards a bunch. So it's another special method, and it's called, believe it or not, add. And what you do is you pass in self and then any other vector. I don't know, I'll call it a V for now. And then the question is, what do we want to return? I want to return vector 2D, and then we'll do self plus v dot x, comma self dot e dot y. Okay, so let's real quick. So self is like if it was A plus V, right? So V is being another object of this type. If that's true, then this will execute this code right here. And what it's going to do is going to go in here, it's going to add the X components, add the Y components, and send it back in as a vector 2D. So that's all that sucker's doing. Hit shift enter, shift enter, shift enter, and then A plus B, shift enter. All right, good. So is that A plus B? Negative 3, 2 and 2 is 4. Yeah, so that is correct. All right, so let's do another one. I'm just going to score, let's see, multiply self and V. And if I multiply two vectors together, what do we want to return? Okay, so we could simply just say that it's a dot product or not. But I also want to have scalar multiplication. So I'm going to let this be if is instance. Let's see, we want to go V and then vector 2D. So if V is a vector 2D, then we want to return the dot product. So return self x times V dot x plus self dot y times V dot y. That is the dot product. So what we're saying is if I'm multiplying, if there's some A times V, so if A is my object and it's A times V, then I'm going to go in and I'm going to execute the dot product. Else, I'm going to try to do this. So what am I going to try to do? I'm going to try to return return vector 2D, right? Because this is scalar multiplication. This would be self dot x times v, comma self dot y. Right, so what we're saying is v is a scalar now and not a vector, not a vector 2D. And then if this doesn't work, I'm just going to say you can't do it. Return or print. We'll just print. Print cannot multiply these two. One. Okay. And we'll get nothing back. All right, so let's find out what happens here. Shift enter. Shift enter, print A, print the transpose, print that. Okay. And we'll add here, let me put a little space in here, and we'll say 3 times, no, A times 3, shift enter. Did that work? Yes. A times B, shift enter. 1, is 1 correct? Minus 3 plus 4, okay, so yeah, that's working. Now here's what's not going to work, but we're going to make it work here in a second. So this says there's no integer and vector 2D business, so unsupported type, operand type. Why is that? Because it's being multiplied on the object is being multiplied on the right. So it's some integer value, and then the object is over here, and so that's a problem. So we're going to come back up here, and we're going to say there's another special method called underscore r multiply, so right multiply, and it'll be self comma v again, and we're simply going to tell it to, so if this right multiply is true, then what do we want to turn is return times v. In other words, we want to turn it around. We want, so this will be a left multiply now, because it was a right multiply. Oops, it was a right multiply, but now I'm going to turn it back around, and then it'll execute this code. So let's see what happens when we do that. Shift enter, shift enter, shift enter, shift enter. Times A. Okay. So there you go. Why is it doing that? Oh, because I'm returning a yeah, I'm returning a vector 2D, so it's always going to be a column vector. That's I'm going to let that be a feature instead of trying to mess around with it. I mean, we could go back and change it if we wanted to, but I'm not super concerned about that right now. Okay. The last two things that I think I wanted to talk about, right? So multiply, right, is the norm, and then set decimal, or yeah, set decimal. So let's do the norm real quick. So what is the norm? It's just simply the 2 norm. We're gonna let it be the 2 norm. The 2 norm is, as everyone probably knows, a Euclidean norm. So if I want the norm of a vector, I mean, this should be a straightforward calculation. Return np dot, let's see, I need the square root. So square root of self dot x squared dot y squared. Very simple. Enter. So let's see. 3 times a dot. Sort of stress it a little bit. Ooh, we didn't like that. Has no object. Wait a second. Oh, there's no such. This is not a special method. All right, that's one reason why I wanted to put these in here, is because I didn't want a special method. So I should have had norm just without the double underscores, right? It's not a special method. It has no idea what to do with that. Shift enter. All right, once you do that, remember you got to redefine the vectors, and then let's see if this good. Hopefully that's the answer. So what, 3, 6? So let me just make sure. Is the 3 squares 9, 6, 36, 9 and 36, 40. Yeah, okay, yeah, so that's about right. Okay. All right, and then the last thing that I want to talk about before we sort of get out of here is the fact that we had this thing called decimal, right? And so right now, in order to set this, we would have to know that it existed, first of all, right? So I'd have to go, if I wanted to print something different, let me go in here and do this. We'll let a dot decimal. Did that, you would get something that looks like that. So that's not exactly what we want for it to have happen. So yeah, I don't want the user to go in and set the parameters of my object. I want them to use a method that I create. So that's the deal there. So anytime that you have a parameter that you want the user to be able to change, you gotta do a getter and a setter. So this is called a set. So set decimal, and then you got to throw in self. You got to go throw in D, and then it's just simply. I mean, it's pretty simple, right? So, but the idea is, I'm going to return back to Spider here. Now I know why I did that. Oh, I don't need to return anything. I just need to go self dot decimal is equal to D. And let's do a new one. Print B. And then let's do a B dot set decimal to 10. And then print B again. All right. And anytime you print B now, it's going to come out until you reset the decimal. Okay. All right, that's all I wanted to talk about today, or not today, but this video. We'll hopefully get this a little bit better, a little bit more fun stuff. We just had to do these, what does it mean to invert? What does it mean to add two of these objects together, and so on and so forth. We'll get to some more of these functions that we sort of think of when we're thinking about, and then hopefully getting the plot as well. All right, that's all I got, and see you guys next time.